Okay, so we have this question. A mouse has made holes in opposite corners of a rectangular kitchen. The width of the kitchen is 16 feet and the distance between the mouse's holes is 20 feet. What is the length of the kitchen? So let's draw a kitchen. So like this. So we want to find the length, this length. And we know that the width of the kitchen is 16 feet. So let's put that over here. Then they're saying that a mouse made holes in opposite corners. So let's say we can take any one of the points. So let's say the mouse has a hole over here and then another hole over here, right? And then they're saying that the distance between the mouse's holes is 20 feet. So let's put that over here. So we see a right angle triangle. So this is C, the hypotenuse, and we've got W and L. So W squared plus L squared is equal to C squared. Instead of A squared plus B squared is equal to C squared. Okay? So let's plug in the values. This is 16 squared. This is L squared. This is 20 squared. Now let's solve. So what's 20 squared? 400. What's 16 squared? 256. Now you see, if you remember SAD map, we have an addition. So let's subtract 256. So then we end up getting L squared is equal to 400 minus 256, which is 144. And then we see an exponent. What's the opposite of a square? Square root. So what do you get? L is equal to square root of 144, which gives you 12. So let's plug in 12 in here. Okay, let's try another one. Okay, so now we have Joseph is playing hide and seek with Lena and Rachel. Lena is hiding 9 meters south of Joseph. So if Joseph is here, Lena is over here. 9 meters. If Joseph is 15 meters from Rachel, how far apart are Lena and Rachel? So Rachel would probably be here, and we know this is 15. So we've got the hypotenuse. Let's call this A, let's call this B. So A squared plus B squared is equal to C squared. Let's plug in the values. A is 9, B is B, and C is 15. Right, then we remember SAD map. So it's always good to draw a diagram. We've got an addition and an exponent, so let's subtract. So B squared is equal to 225 minus 81. So that is 144. And then we take the square root on both sides. So B is 12. Let's put that in here. Okay, let's try another one. Okay, so we've got Bellevue is 12 miles due north of the airport. So if the airport is over here, Belleville is right here. 12 miles. And Yardley is due east of the airport, so that's over here. Let me move this side. 12 miles. And Yardley is 13 miles. Oh, sorry. between Belleville and Yardley. So this length is 13 right here. Let's fix this. This the hypotenuse is 13. We want the distance between the airport and Yardley. So let's call this A. Let's call this B. So B is what we are trying to find out. So A squared plus B squared is equal to C squared. And then you plug in everything as needed. So 12 squared plus B squared is equal to 13 squared. So 12 squared is 144. 13 squared is 169. And then you subtract. What's 169 minus 144? That's 25. So then the square root of 25 is 5. So let's plug in that. All right, so you try these. And it's always good to draw a diagram. Like for this one, you can solve it, but I'll draw the diagram for you. So we've got 3 people. From his home, Reed would have to walk due north to get to his friend Tori's house, and due east to get to his friend Abigail's house. Okay, so Reed is here. There is Tori is up here, and Abigail is up here. So your diagram would be like this, right? So it is 3 miles from Reed's house to Abigail's house. So that is 3. And a straight line distance of 5 miles from Tori's house to Abigail's house. So you get a right angle triangle, and then you can use that to solve for this side. Okay. So in this exercise, we are going to test if the Pythagorean theorem is true or false. Okay, so that's how you're getting yes or no. Now, one hint that I would want to give you, that the hypotenuse is the longest side. So always whatever maximum value you get, you put that as your hypotenuse. So basically that's C. And the other two, you can call them A and B. So apply this and check if this is valid. So 18 squared, 7 squared, 13 squared. Now let's find 18 squared. 18 squared is 324. Put that in. 7 squared is 49, and 13 squared is 169. Now if you add 49 and 169, what do you get? Let's just do simple math over here. So 9 plus 9 is 18. 6 plus 4 plus 1 is 218. So this is not equal. You want to get the same answer. So this doesn't work. So let's mark no. Okay, let's try another one. So again, the longest side is the hypotenuse. If you remember that, you'll be able to solve these fairly easy. So call this A, B, C. So hypotenuse. C squared is equal to A squared plus B squared. 17 squared is equal to 8 squared plus 15 squared. Okay, 17 squared is 289. 8 squared is 64. 15 squared is 225. So 64 plus 225, 982. So this works. So therefore it's true. So let's mark yes for this. Okay. So remember, the longest side is the hypotenuse. Okay, so let's talk about special triangles. So there are 2 special triangles that we will learn about. One is the 30, 60, 90 triangle. So there's a property I'm going to show you. We'll end up proving it at some point. But right now, if you have a 30 degree, 60 degree, and a 90 degree triangle, So let's just draw a small shape for it. So let's say if this is 60 and this is 30, right? So the sides are proportional to the angle, right? So what I mean by that is the smallest angle faces the smallest side. And the converse would be the largest angle faces the largest side. Okay? So the smallest side would be here. So let's call this S. Okay? In the 30, 60, 90 diagram, triangle, and you can verify this. We can do experiments, draw triangles, and see how it works. If you have S over here, the hypotenuse is exactly 2 times as much. So that is 2S. Okay, so that's one relationship you want to remember. And we can prove this idea. We will prove it. But for right now, we'll just solve this way. So S and 2S. Okay? And then the third side that we have is S and the square root of 3. So for example, if I have 30, 60, 90 triangle, and let's say if this is 5, this length would automatically be 10. And we can solve it if we want. And this length would be 5 root 3. Okay, so this fact will help you with solving the IXL. Okay, and there's another triangle that is important. So that's the 45, 45, 90. This is called an isosceles triangle. The previous one is called a scalene triangle. So an isosceles triangle has 2 equal sides, 2 equal angles. So 45, 45. So these two sides are the same. So if I call this S, then even this is S. Okay? And in this case, the third side is S and the square root of 2. So this is what we want to remember. S, S, and S square root of 2. In the previous one, it was S, S square root of 3, and 2S. So if you could remember this as a fact, write it somewhere, then we'll be able to solve these questions. So for the 45, 45, 90 degree triangle, it's S, S, S square root of 2, so 45, 45. And for the 30, 60, 90 triangle, like this, this is S, this is 2S, and this is S root 3, given that this is 30 and 60. Okay? So this will help you solve the IXL. So if we were to use the same logic that we just learned a few seconds ago, now let's apply it onto this question. So what do we have? We have a 30, 60, 90 degree triangle, and if you recall from our diagram, we had 30, we had an S, we had a 90, which was 2S over here, and we had a 60, which was S root 3. Now let's apply that to our diagram. So we have 9 root 3, which is this. What else do we have? We have an S, so let's just call this 9, and this would be 18, right? So our answer is right here. So see, if you remember that, it makes it much easier to solve these questions. Let's try another one. Now, with the 45-degree triangle, what did we learn? So with the 45-degree one, two sides were equal, right? So let's draw the diagram for the 45. So there was S and S, and this was root 2 and S, or S root 2. These are both the same, okay? So we've got 6 root 2. So let's put 6 and 6. These are 45. So if you have that handout in front of you, it will be much easier for you to solve. So let's just hit 6.